Dear friends, welcome to the session today. We are going to do the vacuum cooling on our simulator. So, what are the things that are required for condenser vacuum cooling, vacuum raising, that we will see in this chapter. Now, we have a 210 megawatt simulator, and on that there is a condenser which is a twin condenser. So, first of all, for doing the simulator operations, we must charge the main stream lines, and main stream lines will be charged only after the opening the drains. So MS line drains we have to open to 10%, HPBP, HP bypass and LP bypass drains to 5%. Similarly, HPT and IPT casing and rotor heating drains to 5%. The mainstream line will be charged by opening MS 11 and 12 from field page number 11 or mimic. Now this charging can be done after some vacuum is produced in the condenser. So we can do that afterwards after taking the ejectors in service. For check for this, now you must check before going for this is the interlock selector switch on boiler drum emergency drain, which opens when the level reaches more than 100 mm in the boiler drum. That valve will open automatically, so you have to check that and keep a very close watch on the boiler drum level and maintain it to a normal value of 0 if so required by low load frequency regulating valve FW26. Check the boiler drum level on panel 4 or on the mimic also. You can check it on the mimic. Now observe the gradual rise in flue gas temperatures at furnace exit, at latent superheater exit, at air heater exit, and at economizer inlet, at air heaters inlet and air heaters exit. You can go to, for checking this, you can go to mimic page number 1 and on trend page desk 1 flue gas temperatures you can check on that also. Observe a gradual rise in the temperatures at air heaters exit. Then observe the steam temperatures on the trend page desk 4 drum parameters. Then at about 2 kg per square centimeter or maybe more than that, just slightly more than that, maybe 3 to 4 kg, close the boiler drum vents from field page number 13, and about 5 kg throttle the superheater drains, slightly open the superheater drains to 5%. Then we go for the condenser vacuum buildup. Check that the NRVs in the CRH lines and their bypass valves CR3, CR4 are closed from mimic. Then close evacuation valves EV1 and EV2 from CD5 or from mimic. Then open the air vent to condensers CA1 and CA2 from field page number 14, or you can open it from mimic also. Then open the siphon filling valves MC56, a 15 meter siphon is there, from field page number 9 or from mimic. Then close the vacuum breaker CA6 if it is open from panel number 7 or from mimic. This CA6 valve is a vacuum breaker valve. In case of tripping of turbine on axial shift very high, this valve opens so that the braking is faster, turbine braking is faster. Observe the turbine rotor's differential expansions on panel or trend page number 7 desk turbine expansions. You should check that also because the LPT differential expansion may be rising. Now this is the figure where you are seeing the CRH NRVs, then NRVs, their bypass and the evacuation valves EV1 and EV2. So here are the circled one. First of all, the CRH NRVs and their bypass, and the evacuation valves, HPT evacuation valves EV1 and EV2. In case of trippings, these valves open, so they should be closed now, but these valves will be open, so we will close this. Then open the ejector drain valves from field page number 12. You should open the drain valve first so that you can then put the gland seal steam pressure on controller or AS5 with set point of 5 in auto mode from mimic or from panel number 7. Now open the valve AS81 steam to ejector and AS79 from mimic auxiliary PRDS to charge the gland sealing steam. Open the valve on the air line starting ejector CA5. So first of all you open the starting ejector air valve from mimic or from the mimic air ejection or from panel number 6. Start the starting ejector by opening a steam supply valve AS4 to 50% from mimic air ejection or panel 7. Now observe the condenser vacuum on mimic air ejection or on panel 6. It will take approximately 3 to 5 minutes for vacuum buildup to start. So once the vacuum buildup starts, then you can go for the gland sealing as well as the, so it will take approximately 3 to 5 minutes to vacuum buildup to start. So you should watch the mimic air ejection. There you will be able to see the vacuum that is developed in the condenser. Now once you take the starting ejector in service, you can, in this diagram you can see the vacuum cooling air ejection. You have got a condenser, then CA1 CA2 air walls, then the vacuum breaker wall is also there shown in closed position. Then you have got the starting, the main ejectors, ejector 1 2, then the starting ejector, then the gland steam cooler. So we are starting the starting ejector first. We open the CA5 wall, we open the CA5 wall, air wall, and then we open the AS4 wall, that is the steam wall. So the starting ejector. Then you have got the siphons, different siphons. You have got the MC56, that is from CEP discharge to charge the 15-meter siphon there, and that goes to the drain expander. From the drain expander, and it goes to the condenser itself. So you have got a 15-meter siphon there. So you have to fill up that siphon so that no air from the drain side also enters into the condenser. Then you have got ejectors also. For all the ejectors drains, there you have got 3-meter siphon. So it is not directly connected to air. It is through the siphon. The condenser is connected to, the drains are connected through the siphon. Then vacuum buildup. Now the vacuum pooling has now started. So when the vacuum is around 30 to 35 mm of Hg column, that is about 0.04 kg per square centimeter, take the gland cooler number 1 steam ejector in service by opening the steam supply walls to glands, that is AS9, AS10, 11, 12, 13, 14, HP, LP and HP, IP and LP glands from field page number 14, such that the vacuum of about 450 to 500 mm is available at GC1 ejector. Now close the drains of the steam lines to starting ejector and to main ejectors and GC1 from field page number 12. Now when the vacuum is around 50 to 60 mm of mercury, about 0.07 kg per square centimeter, admit steam to turbine gland seals by opening the gland seal pressure regulating valve such that a pressure of 0.15 kg per square centimeter to 0.20 kg per square centimeter is available at the seals. Now gland sealing. Now check that the gland seal temperature is between 130 to 150 degrees centigrade. This will be available on the desk. Put the control of the turbine gland sealing steam pressure regulating valve AS5 on auto from control panel number 7. The rate of vacuum pooling would become faster when gland sealing steam is admitted. Start both the main ejector by opening their steam supply valve AS2 and AS3 from the panel 7 to speed up the vacuum pooling rate. Open CA3 and CA4 from field page number 14 or from mimic air ejection system. Open the drain valves DM 48, 46, 49 and 47 from field page number 12. When the vacuum in the condenser is around 5 mm of Hg, stop the starting ejector by first closing the airline valve CA5 and then by closing its steam supply valve AS4, and you will observe that the vacuum continues to rise. So you are withdrawing the starting ejector now in this case and taking the main ejectors in service. So you have to take both the ejectors in service, and this way you have to take both the ejectors in service. So now let us do these operations on our simulator. But before we do this, please like, share and subscribe. And please do not also forget to comment. So now we are on the simulator. We have loaded the file and here we are opening the drains. That is the first thing that we are doing. So first of all we open the drains, the superheater drains, the reheater drains. Superheater drains we throttle it to 5%. The reheater drains also we throttle to 5%. And then the main steam line drains we throttle 10%. Then the all the drains those are there. The HPT transfer or the HPLP bypass drain, these are also to be opened by 5%. Then open the casing and rotor heating drains, they also have to be opened by 5%. So you can see here the drains are being opened. Once we open the drains, then we will go further. So the casing, we are opening the casing drains now, HPT casing drains. Now we have opened the IPT casing drains also to 5%. So now from here we have opened the drains. Now we are watching the level also here. The levels are around 70 mm or within our scope. And we will see check up also that the level is being maintained. Okay. So we are on the panel of drum level control. The drum pressure is showing something around 5.620 or so. So we have throttled the superheater drains. We have opened the reheater drains also. And then from the trends here you can see the drum level is being maintained. We have to continuously watch the drum level because though it is on auto, in the initial sessions the drum level may fluctuate and which may trip the boiler again. So you have to watch the drum level also. You see the drum level, drum steam temperature is also increased to 162. Now this mimic is the condensate cycle. Herein we see the deretor and the condenser, the levels also. Here is the temperatures of the flue gases, the leaving the primary superheater and all this. We watch that also, they are increasing. Then the drum pressure is increasing slightly, 6.6 like that. So now I think it is time to, we'll check up whether the FW26, that is the low load line wall, is on auto or not. Yes, that is also on auto, so it will maintain the drum level, but still we have to check it because it is on single element, so it is fluctuating only on the drum level sensing. So that you have to always check the drum level and the other levels also, the deretor level and the condenser level. Now here we close the drum economizer vent. Already the temperature is there, drum steam temperature is there, then the pressure is also more than around 6 kg. So we close the vents. We close the drum vents. Now we see that here the drum pressure is increased to around 8 kg per square centimeter. The flue gases temperature, they have also increased. In the mimic you can see the primary superheater and the other temperatures, they have increased. Now this is the HPLP bypass system diagram. Here you see MS11 and 12 are closed. The evacuation valves are there, EV1 and EV2. They are on interlock, closed on interlock. So we de-interlock and then close. They are open on interlock. So we make it on de-interlock, close them and put them on interlock. So that if the tripping command of the turbine is there, then they will open automatically. So herein we have put the EV1 and EV2 on auto. We have checked up that the reheater CRH NRVs, they are also closed. Reheat bypass NRV and their bypass, that is also closed, that we have checked up. And now we will see the we will now see this is the air ejection scheme, and this is the PRDS, auxiliary PRDS. Here we see that the PRDS pressure, the gland steam pressure, or the ejector pressure maintaining valve, that is on auto. So now we go to the air ejection scheme mimic again, and there we open the CA1 and CA2 valves. Those are the air valves on the condenser line. We open them. We check up with the vacuum breaker that it is closed. So we check up that it is closed. Yes, it is closed. CA6 is closed. Then we open the MC56, the drain valve of the the siphon filling valve. That is, we open that, and from CEP discharge, that siphon will be filled up now. We open the AS1 also, that is the steam supplying to the ejectors. That is the valve that is steam supplying to the ejectors. Now we open the starting ejector air valve CA5. We open that valve, and before opening that, we open the the steam valve of the starting ejector, that is AS4, and that we open 50%, and then we open the air valve CA5 valve, air valve. So when you open the air valve, you will see that some vacuum will be there in the condenser. There you will be observing some vacuum in the condenser. So the vacuum is being pulled now. So there is some vacuum in the condenser. You can see that some vacuum is there in the condenser. Okay, then we open the ejector drain valves also. That ejector drain valve we open that, and now we open the steam supply to the GC1, gland steam cooler number 1. Ejector is there, so we supply the steam to that ejector also. Now we observe that the vacuum is increasing. It is around 24, 25, something like that. So at this time, we will be supplying the steam to the glands, and so that the vacuum will increase at a faster rate. So then we have to open the ejector drain valves also. The ejector drain valves going to the siphon and then going to the condenser. So we will first of all check up whether the level is being maintained. Now we see that the level has increased considerably to around 145, 144, something like that. The feed flow has decreased, zero come to zero, but it is in control still. It is on auto and maintaining. Now you see that the vacuum has come to around 32 or so, 32 mm of water column. So now we will be opening the MS main steam line valves also. MS 11, 12 we will open, so that the steam is admitted into the main line, and the drains of the main line, they are also going to the drain expander. So that steam will be also here. So MS 11, 12 we open MS 11, 12. That is the steam going to the turbine side, or the boiler outlet valve, you can say. Then we open all the sealing valves. So we give supply to the sealing of the turbine, gland sealing of the turbine. So we open the HPT gland sealing valve, both side. Then IPT gland sealing valves, both side, right, left, and again the LPT sealing valves, both sides. So we open all the sealing valves so that the steam is being supplied to the seals, so that even if this steam will go into the turbine, but air will not, it will not come in contact with air. So we open the sealing valves. Okay, now we see that the vacuum will be increasing at a faster rate. Now the vacuum is increasing at a faster rate. We open the steam valve fully, the ejector steam valve, that we will open fully, so that it will open, it will be at a very faster rate. The vacuum will improve, vacuum will build up at a very faster rate. Now See, the vacuum is increasing. Now it is something around 81 or so. This you can check up on the trends also, you can check up, or in the panels also you will be able to see. Now in the meanwhile we will observe that the drum level, in between these two we will observe the drum level also. So we go to the panel, check up the drum level, and when the drum level is correct, then we check up the other level, condenser level, as well as the deretor level. So for that purpose we will check up whether the valves are on auto or not. The valves are on auto. The deretor level control valve is on auto. The condenser level control valve is on auto. And the deretor level control valve CV6 is also on auto. That we check up, so that the levels will be maintained correctly, or otherwise our the BFPs would trip on the deretor level very low. So that you have to check up all the levels, that you have to check up. We go to the auxiliary PRDS also. Here also we see whether the AS5 wall is on auto or not. It is on auto and maintaining a 5 kg per square centimeter pressure. You can open it slightly and then again it will come, put it on auto. So it will again maintain the, it will again close and maintain the, because the steam supply is very less. So it is showing closed position, but the wall is on auto. Now you see, by this time the condenser, there is a vacuum of around 150, 157 millimeters of Hg in the condenser. The continuously vacuum will be built up and it will reach to around 480 or so. So for that we will skip the, we will slightly fast forward, and now you see that the vacuum is now 506 or something like 506. Now this is the time wherein we would take the ejectors in service. So first of all we have opened these valves, DM48, DM46, 49 and 47, all these drain valves we have opened, and then now we are going to open the ejector steam valve. So ejector number 1 steam valve we will open first of all. So we are opening the ejector steam valve first. Ejector 1, AS2 or some, and then open the air valve, that is CA5. So you will see that the vacuum will start increasing. Again we take the second ejector in service. We open the ejector valve, the steam valve fully, and then open the air valve, CA4. So we have taken this both the ejectors in service, and also the starting ejector is also in service. Now we want to withdraw the starting ejector. So we will withdraw the starting ejector. For withdrawing the starting ejector, we will first of all close the air valve. So we take it on the interlock and then close the air valve. We will make it on the interlock and then close the air valve. So we close the air valve first and then put it again on interlock, and then we open the we close the steam valve. So when we close the steam valve, we will see that the vacuum is being maintained, and it will be still rising to around 640 or something like 642, etc. Now the vacuum will it will continue to rise to the normal value. Now in the meanwhile, we will again check up the level. All the levels we are continuously checking up whether they are in order or not. Though they are on auto, because this is an initial stage, so we will check up with the levels also. Now we see that the vacuum has increased to around 635. This we can observe. We have to observe again the LPT expansion also. So that we will just check up going to particular train and the particular going to particular train. So we will check up with the trains. We will check up with the trains and check up whether the vacuum is increasing to normal, or yes, the vacuum is increasing 641 something. We check up with the levels also. The level now, the drum level has gone to -10, but still it is, the drum pressure has increased to 18. We check up the differential expansions. Here you see that the LPT differential expansions has started, and it is going towards plus 0.6. Then we check up the condenser parameters. Here you will be able to see the vacuum. The white one graph is the vacuum that we have started, and now the vacuum has reached to the maximum of 684 mm of Hg. It will show you the condensate flow and etc. So with this the vacuum buildup is complete, and now I take your leave. We will discuss the barring gear in the next video. Thank you very much. Thank you for watching. Please like, share and subscribe. Thank you.